Just waiting for the folks streaming in to actually tune in. So let me know, Ash, when I'm good to go.
It's live.
Live? All right. Hi, everyone. Welcome to the May edition of the Data Engineering Meetup. Thank you all for coming down. We're really excited to have you here. Before we kick off the talks, just like to say a few things. Firstly, thanks to our sponsors for making this possible. So thank you to Snowflake for the pizzas tonight. And of course, Core Innovation Hub as well for the space. So this is the 5th installment. Of course, it's super helpful with the space, and looking forward to more of these right here. As always, we're looking for speakers. So if you are interested, feel free to put your hand up, reach out to myself or Ash. We'd love to hear your voice, to hear your stories. What are you working on? Anything at all, come up and share your ideas. Last but not least, if you're keen to sponsor a venue, actually we got the venue for this year, but for the next year, if you're looking to open up your space, if you have an office, or if you'd like to throw down some food or drinks, feel free to reach out to us as well. We'll be happy to have a chat to you about sponsorship. All right, that's all I have to say. So we're about to kick off with our first speaker today. So today we have Prayas, who will be talking to us about Druid. We have Wilson, who will talk to us about DBT and data quality with DBT. And finally, we have Ahmad and Nathan, who will speak to us about Snowflake. So let's kick us off with the first talk. So Prayas will be talking about Druid today. Prayas leads all things Imply and Druid across Australia. Over the last 2 decades, he has worked across organizations like HP, Oracle, Elasticsearch, VMware. And the list is too long, mate. You've been too many places. Imply has completed just recently a $100 million capital raise, so that's really exciting. Good news for them. So a round of applause there. And really excited to hear more about what they plan to do with that and what the future holds. So without further ado, welcome, Prayas.
I'm not going to talk about how we are spending the $100 million.
Buying drinks?
Oh, the food. Yeah, we sponsored the last pizza, didn't we?
Oh, you did? Yeah.
There's more coming. No problem. Okay. Something coming up? Cool. All right. I'm going to move around a bit. I hope you don't mind. Good afternoon, good evening, everyone. My name is Prayas. I'm based in Sydney. I flew in this morning. Perth rocks because I just done Sydney meetups and Melbourne meetups. This is the largest show up that I've seen so far. So great commitment. Thanks for coming out, guys. It's really good. Eric Shetter, who's one of the co-creators of Druid, was meant to be in town and doing this talk. Unfortunately, because of a few reasons, he couldn't make it today. He's going to be in country next month in Sydney. We're doing a very big event. If some of you can join, that would be super awesome. We're going to talk. We're going to have chats from many different customers and a lot of use cases. What I thought I might do is, I'm not going to go too deep into the technical part, but what I thought might be useful was to introduce the topic, to introduce the technology, to share a lot of use cases. I'm actually going to move around a lot of pages, YouTube videos, blogs, and I just wanted to point, to various different resources that you can basically go, and then I'll end it with a demo of how easy it is to get things done. So before I dive in, just a quick show of hands. Anyone here heard of Apache Druid? How many of you have heard of Apache Druid? You guys don't count. Okay, cool. You've just heard Druid, I think. Whereabouts are you guys from? Yeah?
We'll be using Druid with traffic.
Oh, traffic is cool. I did meet Reagan this afternoon for coffee. That was awesome. Thank you. So yeah, allow me to do that. I'm gonna go through pretty quick through the content. Just stop me, ask me any questions as I race through this. I only have a few slides. I tried to see how I could do this session without any slides, but unfortunately I have to put some slides together. So let's start with the very beginning. As every good thing happens, it happens and started with an open source project. I work for Imply, but at the core of what we do, Druid as an open source is fundamental. 3 good friends got together. They were working for an advertising agency. They had a very big problem thrown at them from a data perspective. Lots of clicks, lots of things coming in, lots of concurrency, low latency requirement, very interactive application that they wanted to build. They looked at all sorts of existing technologies back then. This is 2010, just for context. They couldn't find anything, just decided to write something on their own. Got massively successful in a couple of years. They went and essentially got support from Netflix. They had Airbnb then sign up. They had Hulu, Sky. A lot of companies started contributing to the whole project, and it became a really, really massive thing. In 2019, it reached the Apache top-level project from an open source standpoint, and as of today, about 1,000 plus companies are using the distribution. So this is just some context setting in terms of a very active open source project. Lots of community members. Thanks to some of you who are using it, and for all the feedback that you guys are giving us as such. Imply basically, so think of Imply. So Imply is the company that open source is still hard, by the way. It is tough to take it to production. It is sometimes tough to manage it. So what Imply does is basically the co-creators of Druid co-founded this company called Imply. So if the 4 key co-founders back with Imply, they essentially what we do is we take the open source project, we continue to contribute to it and build it, and we put all sorts of robustness around it, and things like single sign-on, security, manageability, stuff around visualization. There's a bunch of things that we do to help customers push this technology to production as soon as they can. So those are the 4 lovely gentlemen who basically contributed to the founders or the fathers or the OGs of Apache Druid. Thanks, John, for mentioning. We just closed our Series D, $100 million. It puts us into valuation, $1 billion valuation, unicorn, as they say, but means nothing. Funded and supported by a lot of recognized who's who investors like Andreessen Horowitz, Tiger, Bessemer, Khosla, etc. Significant growth that we see and a lot of customers. So that's marketing. Just for context, and this is probably my last slide before I move to a bunch of different things that I want to show you. Just like to put this, or maybe my second last slide. Just to put this in context, obviously, all the better, bigger, brighter, shinier thing happens towards the right in terms of the wave. There are 3 different waves. In the very early days, obviously, we all were trying to solve from a data perspective of how do we store this data? How do we basically put it in low-cost sort of storage? And we looked at all these distributed storage engines, the processing sort of thing. Then we moved to a decade ago where we had technologies like Snowflake, BigQuery, distributed federated query engines like Reno, etc. And it was all about, now that I have data in one place, I have some bit of curation going. How do I query this and how do I get business outcome and value from it? And seconds, minutes, hours was what the latency that was tolerated. And fast forward to today, a lot of customers, users are looking at how do I build something that is highly scalable, highly redundant, something that can return queries in an interactive fashion in milliseconds, not seconds, milliseconds, and can also look at monetizing real-time streams, can monetize batch sort of data, everything that you have in one single system, and do it cost effectively. Because often you think the bills for doing something like this is going to be very, very expensive. How do you get it done very, very, very effectively? So that's what we mean. You click something, it needs to come back in milliseconds. It needs to be extremely interactive, otherwise you lose interest, you lose the attention of your end customer. You need very, very high concurrency, and we are talking concurrency in terms of whether they are API calls that you're hitting with the database, or that's just somebody sitting in the back end trying to drag, drop, and do things as such. And as I said, the last thing was real-time and batch, trying to do that analytics on both real-time and batch. So from an Imply perspective or a Druid perspective, it does 4 things really, really well as a summary slide. Anything that is real-time, where you need sub-second, you need instant visibility, you need to make decisions on the fly in real time. And I'll start giving some examples. Something that supports very, very high concurrency. We're talking of tens of thousands of concurrent requests hitting the system every single second, potentially. Likewise, the flexibility to do ad hoc exploration, and there's no caching happening, there's no magic happening in the backend. It's all the way the whole engine and the storage is structured, and the way compute talks to storage is where the magic happens. There's no materialized view. There is an ability to do materialized view, but it's not. You can query the full data set as such, as long as you structure and model it correctly, and the best sort of cost as such. A lot of things can do it, but doing it effectively, efficiently, and doing it at the right price point is probably what we do extremely well. So here's a scene setting again. Traditionally, most of the business processes and everything is aligned to reporting that is requiring a few analysts to access their data. They create some custom dashboards. They don't change too often. you're happy with week reporting or a month-long reporting. Whereas when you start looking at other on the axis, if you see the speed to understand the data and the time to basically ingest, there are various other use cases that are starting to sort of pop up which need this sort of interactivity and this sort of solution in the backend. So there are two sorts of use cases that we basically enable. The first three are the ones that are for internal-facing applications, and the last box is basically the external-facing application. And all of these are users, customers of Imply Druid, essentially, pretty much. And I'm going to talk about 5 or 6 of these logos in a bit more detail on subsequent slide. So think of, from an internal perspective, these are growth teams, sales teams, business analysts, data platform teams, observability teams who are basically trying to sort of look at a whole heap of data that they're trying to monetize, they're trying to increase customer loyalty, understand the experience, etc. As such. In a simplistic way, what is Imply? Now trying to get into the sort of next session. If you look at, you have lots of things that generate events, and these could be IoT events, this could be machine events, this could be business transactions, this could be anything that you click as such. All of that essentially from a source standpoint gets generated. It can be transported through Kafka, Kinesis, PubSub, through a variety of different sort of streaming engines. You can do some transformations through Spark or Flink or Samza, whatever technology you may be using. That sort of seamlessly gets into the Imply sort of platform, the Apache Druid platform. You can host the Imply platform as a black box on any cloud of your choice, including Kubernetes, including the 3 big sort of providers. And there are customers who do all sorts of crazy things in terms of scale, volume, and performance on the platform. A lot of people in the last 18 months have been asking us, where do you exactly sort of play? And there are so many databases, so many choices. Why you and where you rather. And so we tried to create one summary slide in terms of where do we fit. And obviously the red hot sort of serving tier is where we fit extremely well. And from right to left, obviously extremely large volume, where you need, the updates are less frequent, but you need a very highly available sort of system, and you need to query data that has happened now or is happening now in real time as we speak, is what you're basically interested in trying to monetize as such. So let me talk about some, I don't know if there are any questions, but let me introduce the technology. And let me get, someone who, maybe let me ask you this question. Does anyone know who this gentleman is?
That's me.
Not you. Right. So this, so as I was saying, what I wanted to do now in the next, for the 5 or 10 minutes is try and, we all are very busy. So I just wanted to point you guys to some resources or some, because you're open source, there's a lot of content available and we're busy. So I wanted to, leave you with some ideas, some thoughts that you could potentially take back and see whether this makes sense for you or is this relevant in your scenario or not. And so I wanted these sort of luminaries or these users to basically share their experiences. So I'm going to play some related sort of things that hopefully will give you some inspiration of what they are. So this first one is a good introductory one because I wanted to introduce Druid, and who better to introduce Druid than Max. This is from 4 or 5 years ago. Max currently, he's anyone here uses Airflow, knows of Airflow. He's one of the co-creators of Airflow and also co-founder of Apache Superset or Preset at the moment. He used to work for Airbnb. And I'll probably fast forward to him introducing what is Druid. And this is all available on open website, so you can feel free to essentially go and have a look. And hopefully if I get this right, and if this works.
Airflow, if you're interested in that too. Cool, so I'm going to start with Druid, just kind of set the foundation because it's a really important part of our infrastructure at Airbnb, of our real-time infrastructure at Airbnb. So Druid is a blazing fast real-time distributed column store. I think it has more buzzwords, but this is as many as I wanted to put in here. But it has an open source community that is very thriving. It's been battle tested at large companies. I believe some of the people from Meta Markets are going to be speaking in this conference, and I'm sure they're going to mention Druid. So Meta Markets was the mother company for Druid. Sorry, I'm a little congested this morning. as well as at Yahoo. So Yahoo has a very large install. They're very bullish on Druid, and they also use Superset at Yahoo. And there's like hundreds of companies, presumably, that are running Druid. Druid does support real time, so you can load data in a batch form too. Then we're going to talk a little bit about how we use some of these features later. There's a column store. It is heavily indexed. It is horizontally scalable. The way a Druid cluster works, there's a lot of specialized nodes that take on different tasks. That means that if you want to really optimize and control that infrastructure and ramp up certain classes of nodes on your Druid cluster, you can do so. It assumes an OLAP type workload, contrarily to other NoSQL databases, say like HBase or Cassandra. In some cases, these databases assume that you know ahead of time the kind of queries you're going to run, and it assumes that you're going to leverage that primary index that they have, and you're going to structure your data a certain way. With Druid, it really supports arbitrary queries, and it will perform well whatever you filter on, group by, that sort of thing. So you can really load your data in Druid and then ask all sorts of questions, and Druid will perform well.
So just a snippet, I guess this is from the data engineering meetup in San Francisco from a few years ago. An extremely interesting sort of chat. If you continue through, it's about a 40-minute chat. It talks about architectures, talks about how they use it, and all the use cases that they're supporting in Airbnb. They're also kind enough, by the way, to write an article, and again, full screen, thanks, John. And they talk about exactly what problem are they solving, where they're trying to essentially collect all sorts of information from their infrastructure sort of footprint and try and make business decisions based on all the Airbnb clicks that we sort of tend to make. And so this is an interesting blog if you want to read forward. The other thing I also wanted to do was just to cover, I always get asked, what are your most favorite use cases and your most favorite customers, and what are they doing with the tech? And so maybe we start with, I would say Netflix is probably one of my most favorite sort of use cases. And again, think of Netflix just as a scene setting. About 5 years ago, they had this vision of allowing people like us to access Netflix anywhere on any device at any time. And while that sounded as a simplistic sort of vision from a business perspective, it had a lot of complexities on making sure how do you deliver that experience. And what they use Druid for as one of the core use cases, and there are many, many use cases, is tracking and understanding customer experience. So what does that mean? Every time you switch on a box, whether Netflix, you try to turn it on, they're trying to track on every single device, whether that's a tablet or a machine, a laptop or an Xbox or a PlayStation, whatever that be, how much time did it take for the N red logo to show up? What was the buffering delay? How long did it take for you when you click something? And they use all sorts of data across 190 countries, bring it into Druid, and essentially try and ask questions of, where is the struggle? Where is the bottleneck? Where is the challenge? And they use that to make decisions on where do I place my CDN? How do I improve something? How do I get better understanding of that experience that I'm delivering? And so that's the core use case. But outside of that, there are several other things that they also do at Netflix. Sorry, the audio is bad.
So, and just an overview of my presentation, I'm going to be our Netflix defined instance that are processed by our pattern nodes.
Sorry, I don't know the exact point, but just bear with me for a sec. Okay. So one of the use cases is to try and do all sorts of AWS. There you go.
A couple of use cases, and a lot of stuff is grayed out because it's sensitive information that we cannot show. But just to give you an idea, the various kinds of use cases that Druid is enabling. First is we use one of the dashboards. We use it for AWS capacity planning. And so if we have to monitor the cost of our EC2 infrastructure across regions, across instance types, by accounts, by zone, by region, etc., this dashboard provides that information.
So this talk keeps going. I mean, there are many different things that they do, but you can imagine the scale at which they operate on AWS, spending almost 50 million plus across the ecosystem, trying to find opportunities to optimize that cost. Where are they spending by server, by location, by geography, by storage? Some of the other ones are into payments and security, and quality of experience is the main one. So if you keep following this, this is where they talk about the scale of operations. For example, well, there's also architecture stuff that we can cover, but just trying to get to the right slide on scale. If I get my pointer right. All right, maybe, sorry. This was the, yeah. So just trying to, this was an observability style use case where they're sort of doing millions and millions of rows every single day that they're ingesting inside the platform for every event that comes in that they try to measure. And then there's some data sciencey stuff that they cover towards the end in terms of all the details of how they run standard SQL, because all of the Druid platform can be accessed by standard SQL interfaces. Obviously, they do have some blogs. There is a Netflix blog similar to, and this is a blog written by Netflix, not by Imply or Druid. And again, they talk about architecture, what they do, how they do this. A pretty long sort of blog. I'll leave some of these with John. The third one that I really feel proud and pretty sort of a big endorsement was for Confluent. So this is Confluent's website. Just to set the scene, we're going to cover this in June as well when we do our event in Sydney. Confluent, creators of Kafka, they run Confluent Cloud. Imagine the scale at which they operate across multiple geographies, multiple regions, multiple data centers. Essentially, all sorts of telemetry data is coming from all the services, SaaS service that they provide, and on-premise services into the Druid cluster. And they're doing a variety of different things. They're building products out of it, and they're also using it for internal operations and management. And to sort of go into the architecture, which looks similar, where what I showed before is you have stuff that is generating events, you're pushing that into Kafka, and from Kafka it goes into Druid, and you run products, services, APIs, front ends, billing systems, etc. for your, and you potentially could run for your end customers. Confluent Health is one of the products that they have basically built, but there are many other products and billing that they do. And that same pitch or the same thing is in detail. You could look at, this was from 3 months ago, 4 months ago, where essentially they have a big talk and all they are covering is trying to go into a bit more detail of.
Confluent has grown quite a bit over the last 2-3 years. And it's now to the point where we're running thousands of Kafka clusters, thousands of Connect clusters and KSQL DB clusters, which all provide us with a lot of important data points. We're running all 3 major cloud providers and in dozens of regions across all these different cloud providers. And most importantly, all these services are all multi-tenant, which means that we need to get very good visibility into how they operate to make sure that we provide all the customers the best possible service we can. So as you can imagine, throughout like the last 2 years, we've grown quite a bit. A lot of the telemetry data we generate from the cloud ends up in Druid, as you would imagine, since otherwise we wouldn't be here talking about this. And with that, like we've almost 3x our volumes in the last year.
So I'm not going to go through each slide. I mean, he shows you and talks about complexity, scale, performance. These are internal products that they've done, and these are external products that they basically build. There are things around, if your throughput goes below a particular level, it can trigger an API, and essentially they use that same through Druid to auto-scale the infrastructure just so it can maintain SLA for their end customers. Operations gets a lot of insights in terms of how things are currently running, and cloud products are the health product and the billing product that I mentioned before. And this goes further into the architecture. The same diagram that you saw, it shows you, for example, they're powering some of these flowcharts, and these all, as this Confluent gentleman, the engineer speaks, he covers how they built all these flows, and these are all published externally to folks like yourself. If any of you are Confluent customers, you can basically see all these charts currently being powered by Druid. Before I get to this, Twitter is another really good use case. Twitter runs one of the biggest ad exchange, and the traffic guide folks probably will appreciate this, and probably have heard this quite a few times from the Imply folks. MoPub is a $500 million business on advertising. Essentially, all they're doing is every time Coca-Cola, Nike, whoever is publishing ads and serving these ads, they're trying to get an understanding of who clicked, who actually saw an image. So what are the impressions? What are the clicks? What are the click-through rates? How do you spend and optimize your advertising media spend? They try and give sort of analytics back to their publishers, advertisers as such. Again, operates at massive scale. And this is a Twitter published engineering blog. Again, just trying to point you to external sort of resources. And they talk about why they chose Druid amongst everything. What does the sort of architecture looks like? And the most recent blog, and this is from 2 weeks ago, 13th of May, they essentially are also sharing what sorts of other use cases is Druid supporting in terms of spam and abuse detection, in terms of A/B testing, in terms of all the hypotheses that they are generating, the experiments, etc., including some geohashing and stuff. So Lyft does the same thing in real time in terms of managing the marketplace and matching drivers and riders and stuff like that. I can keep going. I think there are too many of these. The last one that I'll do is Atlassian. They wrote a case study with us a couple of months ago, thankfully. Anyone here using Confluence Cloud? Not Confluent, Confluence. The analytics that is powered in terms of who viewed what page, how often, who was tagged, what exactly happened, all these dashboards at a global level across hundreds of millions of users. Every time you engage with Confluence Cloud, essentially comes into a few different servers. By the way, the setup is pretty complex. It may sound a very simple use case, but essentially they're running this currently across 3 different regions: Americas, Europe, and Asia Pacific. And there's a whole heap of complexity around bring your own key, around data residency, replication, and GDPR and stuff like that. So all that are things that we've solved. And this is again a case study that is available on their website in terms of what they did and how we sort of helped them. So that was pretty much on the use cases. I can probably cover a few more. The one place to look for is the Apache Druid, the technology. You can look at powered by. These are submissions that are done voluntarily by people who are actually using the technology, and they come and I don't know what's happened to my internet. Yeah. So it's a list of about 100 plus customers who are basically using, and there are links to how they use it, what they do, and this is Cisco, Salesforce, Citrix, VMware, PayPal, Visa, lots of names here that you can basically look at and see who's using how, including SignalFX and App Dynamics. A lot of people are using currently the tech. So my last piece is demo. Any questions before I go to a 5-minute quick demo? Anyone awake? Too fast, too slow? So as I said, essentially you can deploy Druid anywhere. It can run on your MacBook. It's as small a footprint as it can be. In about 2 hours, if you go to the website, you download this. This is free forever. This is the open source sort of version that I'm showing. Essentially, that's the chart that you land. It just shows you the out-of-the-box connectors that you essentially have, whether that's connectivity. And this is all native connectivity. You don't need any connectors to anything. You can connect straight into Kafka or Kinesis or Azure Event Hub, everything that you see. Some of those are grayed out because this is currently running off, a demo environment, and we have some fake data sets, etc. But the way this works is, and I'm trying to go to the ingest side first, is just trying to show how simple it is to get things going. Once you've done this in a couple of hours, there's a sort of a walkthrough guide where there are steps that you follow in terms of start, connect, pass. You follow these steps and you essentially go and publish a spec. And that's pretty much it. You start ingesting. The way this works is, for example, let's assume that you have Kafka currently running somewhere in your environment. All you got to do is say you want to connect it to Kafka. Out of the box, it'll just go and read real-time streams. There's no magic, there's no tuning, there's nothing needed. It just goes and simply connects to raw. This is JSON format, of course, as you can tell. There are many. All you got to do is your bootstrap input, your topic that you want to subscribe, and it just comes in. And while we can do a lot of fancy things, all you got to do is just it automatically looks at and connects and passes data. Just understands columns natively by itself. Time is the primary sort of column, obviously, given it's a time series sort of database. We support other box formats like, if I can get this out of the way, JSON, CSV, regex, Parquet, awk, Avro, blah, blah, blah. And if you just keep following the prompts, it essentially just goes, it partitions things. You have the ability, for example, to transform some of these columns, to concatenate some of these columns. You can have some expressions. You can add some columns. There are expressions. And the good part is if you don't follow something, there's help that's available, it can go into expressions and it tells you what sort of expressions it's going to support from the documentation standpoint. You can do all sorts of string, column, lookup, substrings, and things like that. Where was I? And that's pretty much, you can add filter, you can drop columns as you bring in. It's suited extremely well for highly dimensional, highly cardinal sort of data as well. And that's pretty much it. It generates this spec and you just submit. Once you submit, you essentially come to a front end. This could be your own front end. This is Pivot, which is purpose-built for Druid, again, developed by Imply. And it's just simple drag and drop that you can do. This essentially, let me move to this one. This might be interesting. This is like a sales store demo where you're getting orders from multiple global geographies and you're trying to understand what does this mean. This is the data that is coming from your Kafka stream, or it could be coming from your S3 or Google Cloud Storage or wherever you have your data from a batch standpoint or real time. And if you understand non-technical business users can essentially just do simple drag and drop. So for instance, you could do some simple things like, can I understand, which market is this sales coming from? So there's APAC, like this is just simple drag and drop. Can I further sort of go by country, if I can find country? And this is, by the way, in the last R that you're seeing, you have the ability to essentially change this to, can I look at this last 6 hours? Can I, and this automatically refreshes, so it's running on a smaller footprint and there's too many things, so maybe I can just limit this to the top 5 rows as an example. While this might look like similar to Tableau and some of the other sort of UI, this sits natively and integrates into Druid. And say you want to now look at adding some more measures where you want to go and add, in addition to sales, you want to look at profit. So I can get profit, and you want to look at how does this compare to previous period. And just like that, you can keep slicing and dicing this particular data on many different, right up to shipping country into region, into like, you can just keep going as deep. I mean, just to give you a sense, and the formats can be changed in terms of the visualizations. They could be heat maps out of the box. They could be sunburst charts, etc. Yeah. So that's pretty much what I wanted to cover in terms of it goes from storage to from ingest to storage to query to visualization, all in one package that you can put anywhere and operate at scale with low latency and high concurrency. That's the Druid platform for modern analytical applications. Did I go over?
A little bit. That's okay. Questions?
We are always hiring, and there are some T-shirts at the back. Feel free to grab them when you are on your way up.
Any questions for Prayas before we let him go? Awesome. All right.
Thank you.
Thanks, Prayas. Round of applause. Thank you. Thank you, sir. All right. Awesome. Thank you so much, Prayas. That was an awesome presentation. All right. Next up, we have Wilson McQueen. Hopefully I said that right.
That's good enough.
Good enough? All right, pass. And he's going to talk to us about data quality with dbt. Show of hands here, how many of you are using dbt today? Just, wow, all right,
Whoa.
3 hands. All right, hopefully we'll see more the next time we run this meetup again. dbt is awesome. I'm not sponsored by Ray. So a quick introduction to Wilson before we get him up. So Wilson is a software engineer who is passionate about data and open source technologies. Wilson loves to apply traditional and modern software engineering principles to the data space, such as CI/CD and infrastructure as code. All right, so a very good man to learn things from. Wilson has implemented multiple data platforms in various large enterprises across Australia. I think BHP being the most recent that you worked on.
Correct.
Yeah. Yes. All right, so everyone, this is Wilson, and over to you. Thanks, mate.
Thanks, Jonathan. All right, I'm going to try to do some other presentation over this and see if that works a little bit better, but still going to need to go back to my laptop. All right, good evening, everyone. Thanks for coming. I just want to start before introducing myself formally. I want to start by saying thanks to Jonathan. Like, it has been amazing. I'm here presenting to you guys, giving the opportunity as a small setup to showcase what we're doing, and I haven't paid a cent, really, and it has been an absolutely smooth process. So, guys, seriously, thank you for what you're doing here. It's amazing. Ash, I just met you, but also I'm equally thankful. All right. So, what are we going to be doing today? What are we going to be talking about today? Data quality with DBT. Before we jump into that, I just want to quickly tell you a little bit about myself and what I'm doing, what we're doing. So I'm from Diverging Insights. It's a new startup in the data space and started here in Perth. And we got big ambitions, all right? So we really want to change dramatically the world of the data world here in Australia. Quite a few things we're doing. So on the one hand, of course, we got a consulting branch, right? So, we got quite a few opportunities happening there. So we're a consulting partner of Fivetran and DBT Labs, or something which is very good for us. And on top of that, also, we are working on open source. So we're actively developing a new open source. Right now, we are in stealth mode. Right now, really cannot tell you a lot about it, but we are going through that phase where we sit in the company, trying to get some funding happening. It is a full-time job, folks, but it's not easy, right? Getting people to give you their money, so you can invest it. So yeah, we're going through that, and hopefully we're going to be successful. Hopefully soon in the future, you guys are going to be hearing more about that as a successful story. Hopefully, that's it. That's the two key things that we're doing there. All right, so let's go back to data quality. I'm going to try to keep things simple here. I probably only got, I think, 3 slides. That's it. And the reason being is because data quality is a massive subject, right? We could speak for weeks easily about data quality from an enterprise perspective, about data strategy, about data governance and whatnot. And the company has got a maturity for data quality, and what's the metrics, and how do we achieve that, and all of that. And then from a bottom perspective, we got the tooling, right? So tooling-wise, there are many options how you can go about it. And also, I'm not trying to imply here today that DBT is the final tool for that. I'm just trying to show you how you can be creative with DBT, which is an awesome tool for sure, and use it for creating some really nice, simple data quality reports, which I believe there are not many around out there, just because it's a complex subject. So without further ado, let's see if I go into my first slide. That's what we're trying to aim, right? So today's presentation, I'm gonna deliberately do it backwards. That means we're gonna start from the outcome. I'm gonna show you what the outcome is gonna look like, and then we're gonna work our way into the guts of it. Okay? So this is what we're aiming to do. I don't know if you guys find that pretty awesome. I do. It takes a lot of effort to do something like that, or it's not something that you commonly see, and it's something that definitely most data people are quite keen to be able to do. All right. Here we're looking at quite a few things, folks. Quite a few things. On the one hand is how we could visualize data, all right, which is also a complex subject on its own. There are many different ways on how you could visualize quality. There is no final way. There is no prescribed way. This is one way that I'm just trying to get people across as an inspiration. And by the way, the inspiration that I got for this was this is a very mature space in other areas. If you go to the manufacturing companies, they do quality very well. So that is a really good spot for you to get some inspiration. All right. So in terms of the different areas that you find there, you can see that we got accuracy, completeness, consistency, timeliness, which is eyes on the prize. Is the things that matters, right? It's the thing that your managers want to see. It's the things that you folks want to see in the data, all right? Where did I get that from? Well, there are already a lot of work happening on that, all right? So we got the classic DAMA or DAMA, which is one of the key bodies for data quality, which talks about the many dimensions around quality. And by the way, there are not only 3 or 4 or 5, there could be 20, depending on how you approach the problem. And there is also a nice standard I'm going to be showing you soon seriously, there is a nice standard around quality data, quality specifically, that talks about this dimension. So that's where I took those from. So that's the easy part, I guess. Then it comes down to how do we measure those, all right? Which is what we're going to be seeing next. All right, so what do we need for this? We need 3 key pieces in here. In here, what are the key pieces is? Well, the first one will be DBT, specifically DBT Core. Mind you, there is something as well, DBT Cloud. I don't know if you're familiar with that. DBT Cloud is the managed version of DBT, so you don't have to do all the installation by yourself and so on and so forth. And in this case specifically, I'm mentioning DBT Core just because DBT Cloud will give you already some of these goodies. Mind you, I'm not a this is not sales pitch, I don't work for DBT Labs, right? But I'm telling you, DBT Cloud, if you were to use DBT Cloud, you will get at least source freshness, something which is called source freshness that you put on top of your sources out of the box. But that's not the case with DBT Core, which is really a command line, right? I think only one of you folks raise your hands around DBT. And if you're not familiar, DBT is largely a command line. It's written in Python, and and that was you. And you run that command line, and that will allow you to do a bunch of transformation of your data to the command line, right? So it's fairly powerful. So that is the key ingredient there, DBT Core. The next one will be something along those lines, right? So you need somewhere where to put your data, right? Where you put your results around your data quality. So Nathan's going to be smiling on this one, Snowflake. So yes, that's one option for sure, but it's not the only option, right? So if that's not your cup of tea, DBT also supports things like Spark, and you can use Postgres and Redshift and whatnot, whatever the back end of your company that you're using, right? The point being is that you need a place where to store the results of your data. And last but not least, you need a visualization tool. All right, again, I'm just picking Power BI, but I've used quite a few of them, whatever suits you, right? But those are 3 things that you're going to be needing there. All right, let's see what else have we got. Before I jump into this slide, let me just go back to my laptop and show you a couple of screenshots on how this is going to work. So the first thing I wanted to show you today is if you go into Google and you search for DBT Package Hub, all right? Actually, let me see if I can do this live with you. Oh, it's not such a good idea. DBT Package Hub, all right? It will take you to the hub of packages for DBT, okay? This is a hub for the community. By the community, a lot of people are contributing the work in here. It's actually quite useful if you're using DBT. Think of those as plugins, connectors, adapters, right? Things that are extending the capabilities that normally you get out of the box from DBT. In here, one of the key things that we do is, if you go down, you will see our company there, and we go 2 packages there, DBT Data Quality and Snowflake Environment Setup. So those 2 packages are actually from us or made by us diverging insights, hence one of the key cores or tenants of the company, which is, we got 3. So one is data, the other one is software engineering, and the last one but not least is open source. So yes, we are contributing back to the open source community. It's one of the key things that we want to do. It's one of the key things where we want to lead the way in Australia, where we feel that we're just a little bit behind with respect to the rest of the world. So yes, that's one of the key contributions, or one of the initial contributions that we have made to the open source community. And you can get that data quality report built using that plugin called DBT Data Quality, which I must say right now is getting a lot of momentum as well. So if you go there, it will give you a nice README on how to use it. Okay, so how to install that as a package. Using the DBT language, jargon, they talk about packages, right? It's not plugins, it's not connectors. They use the word they use is packages. So when you go into the package hub, you download packages, and the way how to install them is like so, all right? That's pretty much it. I will show you how that works in a sec. But if you scroll down, it will give you also a detailed information on how this package works, all right? So it's a fairly comprehensive README file, and it's also starting with a nice video there, gift video showing you how things work and the kind of features that you will get out of the box from the plugin. So what are the key things that I want to highlight from this? Well, let me just start with this diagram. I don't want to bore you with a lot of diagrams, but from this diagram, the key thing that I want to highlight there is that this what you see here is pretty much what the plugin is doing. All right, so it's doing a lot. And the way how I see it, you can use the plugin two ways. One, you can use it as an inspiration to write your own plugin, all right, and start from scratch and work out, reverse engineer what we have already done, someone else have already done, for you to be able to do the same thing or a similar thing, which a lot of us we do. So that's one thing. Two, also, it will give you a good description of what's going on, so then you can actually help us to maintain the plugin, which is the other key thing about open sourcing, right? So one thing is about contributing to the community, but another thing is about the community also helping you to maintain and contributing back, all right? So absolutely, please, if you find that you can contribute, just raise a PR and have a look and let us know where we could enhance the plugin. The key things that the plugin does, if you look at it, it's like a mini data warehouse, really. It's moving data, it's transforming data, and then it's also putting the data in a format so it's available, accessible to others for consumption. The key things I wanted to highlight here is, let's see, the standard process for ingestion. You guys are not familiar with DBT, but how many of you are familiar with Snowflake? Can I see some hands? Two, a little bit more. Nathan, you don't count. And I'm glad that you raised your hand. So the classic process when you ingest data into Snowflake or any other data warehouse for that matter, guys, right? What's the classic process? If we're talking about the warehouse is on the cloud, right? It's on the cloud. You need to get your data from on-premise or maybe another third-party data source, and then you're going to be moving that into your destination, and that's normally the loading process of your ELT process, right? And then once it's there, you're going to be transforming that data in there, right? So the key things I wanted to highlight in this scenario, in this example with Snowflake, all right, and you can extrapolate that to Databricks or any similar warehouse, is that you got a bunch of files in here that are being generated by DBT. If you remember, I told you at the beginning, at a high level, I get it, at a high level, the DBT is a command line tool, which means you're running the command line. I'm going to do probably a quick demo just to give you a bit of a feeling. You're running the command line, and then when you run it, you get an output, right? That is the basics of command line working. So in DBT, one of those outputs is called source.json, the other one is called manifest.json, and the other one is called runresults.json. These are JSON files with some logging information on the data processes that you apply through DBT, okay? So in this case, essentially what's happening, by the way, in using DBT language, these are called artifacts or DBT artifacts. So what happens is that you got a piece of data or a piece of model, right? You run some transformations on that model, and then after running that transformation, you're going to end up with these files. And this file are just reporting on those transformations, on those processes that you did. So then what the plugin is doing for you is grabbing those, putting them into a staging area through a loading mechanism, which I'm going to show you in the code how that works. It's just a bunch of SQL happening there to do the loading mechanism. And in the case of DBT Snowflake specifically, we're using the Snowflake put command, right? Which is a fairly common command to do so. That's one way of doing it. And once you've done that, from then on, you can just easily then stage the data and then put that information into a table, all right? Mind you, you still got the option to either do it internally through an internal stage, or if you got your own loading mechanism, which is highlighted here as my loading mechanism, I don't know if you can see that, but if you got your own loading mechanism, that means that you should be able to go bypass the internal process and the whole loading process being done through DBT and put that into the staging table. From then on, what the plugin is doing is just generating a bunch of data models which are specifically aligned towards giving you a data quality table or view or entity that then you can choose. You can get Power BI, something like Power BI on top of it, and report on it. You might be wondering, Wilson, what about all the logic? What's going on inside? Well, there is a bunch of SQL that's happening, I must say. But if you want to know about the SQL, just go through the code, right? Just review the code, download the code. It's open source. You should be able to see what's going on there and see all the logic, how things are being, there are window functions, there are group bys, all these sort of things to make the data into the presentable format. How am I doing with time?
About 9 minutes
To continue talking, boring these people. All right, so that's the overall process of what the plugin is doing there. I'm just gonna move on quickly from then. And then I'm just gonna give you at a high level the process on how you configure the plugin, right? Because what's gonna happen is probably statistically, maybe one of you, two of you tomorrow or following week, you're gonna remember the crazy Wilson guy talking about data quality, and you might want to test out the plugin. So you're gonna come to this page, and then you're gonna be wondering, what do I do next, right? Once I got my DBT installed. Well, one of the things that you need to do once you set up your package is specify some optional variables. This is instruction DBT on how to instructing the plugin within DBT how to work at a high level. All right. So these variables are all optional, so you don't have to specify them if you want, if you don't want to, if you don't need to. But it's good to know about them. Okay. So one of them is, for instance, I want you to write the output of my data quality in this database, or I want you to use this specific table to write the output of my data quality tests. Okay. And if you don't do that, well, this is the default value that you're going to be getting. So once you run your DBT process, you know that by default, you're going to be getting these values there, okay? Let me see if I can scroll down a little bit here. So those are the high-level qualities. Just when using the pointers, not that precise. And these are the instructions how you will run the plugin using DBT Core. Mind you, the plugin is also fully compatible with DBT Cloud, if that's your cup of tea, right? It's another version of DBT. And yes, it has been tested there and it can be equally used there as well. The instructions there are fairly simple. You got two options or two processes that plugin is capable of running and reports on. So one is the DBT source freshness process or information. Within DBT, when we talk about sources, we're talking about the raw data, all right? That is related to your origin or your database, right? So it's not about Snowflake. Think about Snowflake, your warehouse. The warehouse is made of or populated by data sources, right? So in DBT, those are sources, and then we are able to report on the freshness of those sources, which is really, really cool. That means that you should be able to see things like, okay, this source is 20 hours behind, right? It hasn't been refreshed during the last 3 days, right? It's a really nice feature. So if you're using source freshness within DBT, these are the 3 lines of code that you need to run in order to be able to report on that, okay? Similarly, and I guess more importantly, just scrolling up a little bit there, you've got data test, which is one of the key things that the plugin will give you, all right? Why? Because there is no such a thing right now. There is no such a thing in the community. No, it doesn't exist, and hence the plugin, okay? Hence the gap that it's trying to solve for or close. And essentially the way how you will use it there is you run your DBT test, which is a command in DBT, which means you're telling DBT, I want you to run all these tests on my data, all right? Another powerful feature from DBT. So it will run a bunch of scripts and will test your data against various criteria defined for you programmatically or by you programmatically. And then once you run your tests, that output will be stored into a JSON file, right? So what we're gonna do next is we're gonna load the JSON file using the load log tests macro. Macro is the word in DBT for a function or for a stored procedure. Think of it as a kind of an analogy. And once you loaded your JSON with the outputs of your test, then you are able to populate the models with your outputs from your tests. That's all it takes. all right? Kid you know, download the package, set it up. Mind you, I'm not here to impress on you. That's going to take you five minutes or five seconds. It's going to take some time because you do really need to understand what you're doing. But once you know what you're doing, you know your way around DBT, this should be really a piece of cake, right? Fairly straightforward. So then the output of that is going to be, well, what you guys saw from the beginning already, right? So the beautiful dashboard that we built in Power BI on data for data quality with those dimensions. Those dimensions, by the way, you can customize those. So the plugin, essentially, you provide those as a list, and you tag those in your DBT metadata, right? So essentially, what you do is you go into your YAML files within DBT, and you're going to be adding those as tags. So you can put whatever you want to put in there. It's up to you. You define that model. That's the other thing. It's not about me defining the quality for you, how your company see it. So maybe the quality for your company is going to be cat and dog. You can tag as cat and dog, and that's what's going to be showcased here, right? It's just a tagging mechanism, and whatever you put in there, the test output is going to be tagged against that, and then that's going to be made part of the output of the model. All right. So I think probably we're getting close to time. So how are we doing with questions? Do we have any questions? All right. Yes.
Example following the
Yes. The question.
the example is shown here using JSON files to support other formats as well, I assume.
Yes. One of the key things here.
Can you repeat the question?
Oh yeah, sure. So the question that we got here from Luis is, can we support other types of file types besides JSON? And the answer is, well, within DBT, what happens is once you run your DBT command, you're going to get a set of outputs. Those outputs are always going to be in JSON. But Luis, still your question is really valid, because what's going to happen is that these JSONs are versioned and they are maintained by DBT. So within your context, I'm going to say right now the plugin only supports version 3.0 of these file schemas within JSON, which are again officially versioned by DBT. As soon as the schema changes, yes, the plugin is going to have to be updated and adjusted. And also, right now, we don't support, for instance, version 2 or 1. If you're using an old version of DBT, like version 0.1 or below 1, yes, probably the plugin might not work for you. So you need to make sure that you are in the latest, which is version 1, using the schema 3, and then it should work. So yeah, really good question, Luis. Thanks. Any other questions there?
Yeah, related to that, is the versioning specific to DBT Cloud, or you can also use it?
Yeah, good question. Yeah, and the thing is, what happens there, just repeating the question from Russell, is the versioning only specific to DBT Cloud, DBT Core? What happens is that there is some slight discrepancy between the JSON files generated by these two tools. Even though it's the same tool, right, same company, the JSON will be slightly different, all right? So I have tested them so far, and Russell, yes, they are fully compatible. Having said that, I do know that some people have been reporting some discrepancies and lack of compatibility with JSON in the cloud. Unfortunately, I haven't come across that scenario, and also it's something that I'm quite keen to start adding to the automated testing of the plugin, all of that. But so far, yeah, DBT Core, and it has been tested in DBT Cloud as part of the set of projects that have been implemented on there without any problems. Any other questions?
So in terms of this output, how do you define accuracy or what contributes to that?
All right, so really good question. So the question that we got from the audience is, in terms of output, how do we define accuracy, right? How are we coming up with those numbers in those dimensions, all right? So we got two problems here going on, folks. One problem is, how do we define data quality, all right? And that is a philosophical question. We could have a big fight over that, right? Kid you know, like seriously, right? How do you define data quality? What is data quality? That is a corporate question, and that's something that it will take summatry to the company to define, all right? So there is a nice standard on that. There is DAMA as well around data quality, and how a company, a given organization decides to define it is up to them how they, internally they don't so, right? So to answer your question there, what we could say is, let's say company, I don't know, MMM decided that for them data quality gets measured around completeness, accuracy, and consistency. But on top of that, also we got crystal clear definitions of what those metrics are. All right, I'm talking about semantics, right? Writing down a nice paragraph telling you exactly what they mean, what that means, right? I don't know, just to give you a quick example. Completeness, it means that none of the values around gender are missing. Oh, good, we got male and female. Oh, hold on a sec. Is it really male and female? Oh, is it gender of birth? Is it gender? It becomes a problem of how you want to define that depending on the organization. So then that's why you need semantics there. So that's problem one, all right, your dimensions. Once you got your dimensions, the next problem that you need to define or solve for is how do you calculate those, okay? So in this case, the plugin, what it's doing is a fairly simple calculation across, it's just a weighted average. Simple answer is a weighted average. So essentially, if you got three variables that are measuring completeness and one of them fails, then this will show you 75%. Because one of them fails, the other one was successful, well, it should be really 66.666, if you know what I mean. Yeah. So right now, that's what it is. It's a weighted average, but then that's something that definitely you want to review and tweak to your needs, for sure. Hopefully that answers the question.
And I was also interested to see how you define that in a technical perspective, like in PPT. How do you define those rules?
Oh, okay. The following up question there is, how do we define those metrics or calculations within DBT? We still got time for that question?
Yeah, 1 minute.
1 minute, okay. Short answer is you got two mechanisms. One which is really new, which is called DBT metrics, all right? And is aiming to the concept of measurements from Kimball, your classic Kimball data warehousing, that concept of measurements. But that's too new. In this case, the metrics are just being calculated by simple old-fashioned SQL. That's really, there's nothing fancy going on there other than old-fashioned SQL to calculate those metrics. All right, so I got probably 30 seconds left. The last thing that I want to show you, just to say bye, is this, folks. Just in case you were not aware, there is something called Data Science for Business Conference and Exhibition. It's happening this year thanks to we're getting COVID-free, all right? So we're getting there. Woo-hoo. And this is being hosted by the WA government together with Curtin University. If you didn't know about that, well, now you know, and we're gonna be in that conference as well. So feel free to come by and say hi, all right? Also, we got some goodies here, some pen drives and stickers. I'm gonna just put them over there so you guys can help yourself as well. Thank you, everyone.
Thanks, mate. Sorry about the cake. No, all good. All right, awesome. Thank you, Wilson. Oops. Hello. Thanks, Wilson. All right, up next, we have a couple of folks from the good old Snowflake gang who are here to talk to us and give us an introduction to Snowflake. So I saw a couple of hands, maybe 3 or 4 went up when we asked who used Snowflake. Probably half of you haven't heard of Snowflake or used Snowflake yet, so this is actually very good timing. So a bit of an introduction to Snowflake. Feel free to help yourselves with some drinks and water as well if you're feeling hungry and tired. So I'm going to introduce our speakers now. So we have Ahmed. Will you be speaking tonight? Yeah. All right, awesome. Ahmed is a data analytics leader with over 15 years of professional experience across Australia and international with clients of different shapes and sizes. Nathan is a solutions architect with Snowflake, and funnily enough, 15 years of experience. So you guys have been started around the same time in your careers, probably. Yeah, and then you've been working in the data analytics space with government agencies and education sectors and banking and a whole bunch of different types of clients on data solutions on-prem and on cloud. So I'm very excited to have you both here. Handing you guys the microphone. Yep.
Just make sure I get connected. Just let me know. Yep. Well, hello. Do you want to go to the next slide right now? Can you guys hear me okay? I'm assuming yes. I'm going to keep it up here, I think. So actually, funny story, me and Nathan actually went to university together. So I've known him for a very, very long time. And we followed each other around various companies. I think we've worked together maybe over 10 years. Yeah, so it's actually really nice to be standing up here with Nathan. We go way back, and it's equally nicer to sort of both be working at Snowflake together. So from a Nathan perspective, and I'm just gonna give him some bad props, I've not seen a problem that he hasn't been able to solve from a data perspective, so he's quite a legend as far as I'm concerned, anyways. Today we're going to be talking about a bunch of things. I'll tell you a little bit about the Snowflake platform, how it's a little bit beyond that, and why we refer to it as a data cloud. We'll touch on the fact that we support all data types and we cater for all developers. All right, so the Snowflake platform. So we support many workloads. So we've got data engineering capability, and you can, I suppose, off of Wilson's presentation, you can hook us in with, there's a wide ecosystem of tools that you can integrate Snowflake with. dbt is one of them, and we love dbt. I equally love that Wilson had a really big Snowflake logo when he was talking about us, so thank you. There's various CDC tooling that you can connect with Snowflake, get your data in various, you can connect to Kafka, you can stream data into Snowflake, you can bulk load into Snowflake. We've got inbuilt capabilities for ingesting data and for transforming data. We are both a data lake and a warehouse in one. So that is something that is quite cool, and I'll explain a little bit more about that. We do have inbuilt data science capability as well as leveraging the wider ecosystem from that perspective. So if you use Dataiku, Data Robot, SageMaker, and there's a stack load more, we can connect them all with Snowflake. We're also, we can sit behind sort of data applications. We enable data sharing built in within the platform. So organizations that are on Snowflake can easily share data without pipelines. Ultimately, this platform enables you to ingest data from various source systems, and at the tail end of that, run your self-service, your operational reporting, etc. And even monetize your data set should you want to do that. We are SaaS, we're a SaaS-based platform, and we can be deployed on Google, AWS, or Azure. So you get the capability and the selection to be multi-cloud if that's something that you're interested in. I suppose from a common data management design pattern, this is something that you probably all have worked in some way, shape, or form, something that looks like this. So raw, you bring in your data from your various sources into raw, you conform your data. You might have reference data that you need to map against. Ultimately, at the tail end of that, model the outcomes. And you've got obviously your various techniques, your conventional models, your data vaults, etc. At the tail end of that, you have your consumers that you need to provide the data to. So be it data science or be it your analytics workloads. This is typically what most organizations like to implement. And historically, that's sort of been broken down into these sectors. So data lakes and data warehousing or data marts. And usually organizations would run around finding data lake technology, and then from there, finding data mart technology or data warehousing or whatever it is that you want to do. And I suppose what that comes with is one, building integration between the various layers, managing the various layers, governing your data across the various layers, the cost of technology, the cost of people, and the cost of management. So from a Snowflake perspective, and obviously you'd expect that we'd say this, but we do believe it's true. We do data lake and data warehouse in the one platform. And we've got data governance capability that sits across all our workloads. So that is something that you can do from a Snowflake perspective. In terms of how you'd approach those data zones, if you like, or that common design pattern, data from the sources can, using Snowflake capability, you can ingest data continuously via Snowpipe capability, and this would leverage, pulling data from your S3 buckets or from Blob or ADLS. You can also do batch copy-in, which this is where you schedule your data sets. You can work with CDC or ETL tool from the wider ecosystem. And ultimately, that data will come into raw. Then we have capabilities called streams and tasks. Streams will allow you to work with just the delta since your last transformation into your model data sets or your conformed data sets. And tasks is a mechanism that allow you to schedule your processing. That capability from a tasks perspective can run as serverless, means that you don't have to define your compute for what it is that you're doing. One of the unique things from a Snowflake perspective is we are able to target compute for the specific workloads that we're running. So I can have compute for ingesting data, I can have compute for transforming data, I can have compute for analytics and separate compute from a data science perspective. And one of the things that I think we stand out at is our ability for our compute to turn off automatically when it's not in use, and to instantly turn on the second that compute gets requested or somebody runs a query. So I suppose from an evolution of data management, we all love to talk about data warehouses and data lakes and what have you. But there's a world beyond that. There's a world of data that lives beyond your ecosystem of your organization. We like to look at the data in 3 different tiers. So I need to bring it closer. The first tier is the data that lives within your organization. And then there's a tier beyond that. This is your ecosystem. It could be your suppliers, your partners. Think about this, any customer that has, for example, a Snowflake instance that lives outside of your environment, or even those that don't have access to Snowflake and live outside of your environment and you want to give them access to your data. And then we surround all of this with a marketplace. This is our app store for data, if you like. This is where you can go at a button click, request weather data or demographics data or health data or banking data, whatever it may be, and have that instantly appear in your environment. So I guess we do have the capability to share data, and sharing data without the need to build in pipelines. So if I have an instance of Snowflake, Nathan has an instance of Snowflake, I make that data available to Nathan by a few button clicks and some selections of what his account is and what data I want to make available. And I think if we get time, Nathan's going to show us a little bit of that today, maybe. I suppose the flip side of that is understanding what you'd have to do if you were working with data that lived outside of your organization at present. For example, you'd go to a provider and say, well, I need to get the data would be extracted and put on FTP somewhere. From there, it'd be downloaded, ingested into your tooling, into your data platform. And in fact, every time you wanted to repeat that process, you'd be building a pipeline to do so. So I suppose what makes Snowflake a data cloud is we've talked about sort of the 6 major workloads. We've got the data marketplace. There's roughly about 150 providers, each of them providing lots of various data sets onto the platform. You can query, as I mentioned, various data sets, be it health data or banking data, finance data. There's a lot of data there. FactSet, Noema, lots of providers from that regard. We've got the ability to share data directly with other customers that have got sort of Snowflake accounts without pipelines. If somebody doesn't have a Snowflake instance and you want to give them access to your data, there's this concept called a reader account, which you can enable them to have access to your database without giving them access to your main instance of your database. And equally, you can create your own data marketplace within your organization called the data exchange. So that in effect becomes a catalog of data that you provide. We do support all data types, so structured, semi-structured, so JSON, XML, Avro, Parquet, ORC, can all be brought into the platform without in an as-is format. So we talk about the 3 V's of big data. From a variety perspective, we support all. And we can bring those, for example, all that semi-structured data in without actually flattening the data, without any transformations. We can bring things in an as-is state in true raw format. We do also have the ability to both store and process unstructured data. So things like images, videos, audios, PDFs, and documents are all possible. We do have geospatial support as well. So, points, line strings, polygons, GeoJSON, WKT, WKB, all possible. And we do have the functions as well to support that from, distances, dwithins, etc. are all there. Everything that's stored in Snowflake will natively be picked up by your analytics tooling. It will be plotted in the various maps. But more importantly, at the moment, we are supporting geography. Geometry is on the cards. It's in private preview at the moment, so we're expecting that probably in the next couple of months. From a processing of unstructured data, and Nathan's going to run us through a really awesome demo in a short while, we are able to bring in unstructured data. As we bring it in, we've got these directory tables that will store things like file paths, relative file paths, URLs, size, etc. And that can be used to query the data. Snowflake will generate two types of URLs, pre-signed and scoped, and you have control over what you give people access to. And ultimately, you can control access to all types of data within the platform through governance, security, and RBAC controls. And ultimately, we do have the capability, which we'll touch on in a second, called Snowpark, which gives us the capability to run Java functions or external functions and process this data. So if you wanted to take, for example, an image and classify, or if you wanted to transcribe an audio file or scan a PDF document and push that into a table, that's all possible. We also cater for any developer. So Snowpark is a framework, and I do apologize, I'm talking really fast. I'm trying to give maximum time to Nathan because I know that's what you guys want to see is the technology in action. So Snowpark is a framework. It's a new developer experience. Snowflake used to be just SQL. We decided to cater for more than just SQL developers. We know that other developers exist. So we've released the capability to code in your IDE of choice and your language of choice. So Scala, Java, Python's in private preview, and it's going to get released next month. And with the ability to push down that logic into Snowflake and run it there as well. So what this actually means, from a SQL engineer perspective, yes, you're going to be writing your straight SQL, but from a data engineer that uses Java, Scala, Python, you can natively write in your language of choice, but also in your familiar constructs. So you can write out your data frames and actually have those be pushed down into Snowflake and execute there. Java functions, so if you are using an ML tool, you build your models where you're training your models, etc., and then you're done with that. An example of that is I want to take that model, I'm going to push that into a Java file, push it into Snowflake, and I'm going to run regular transformations, scoring, inference, etc., directly within the Snowflake platform. You can then do that. And what this means is when I'm running my ML processes, I'm not having to extract the data and import the data every single time I'm running those processes. So it just simplifies some of that and allows you to use some of the compute that you already have for that purpose. From a Python perspective, this was a bigger challenge because we wanted to make sure that everything was a little bit more secured, and we wanted an effective way to manage packages, deployments, etc. So we teamed up with Anaconda. And the idea here is we wanted to cater for package deployment. We wanted to work with a set of curated packages that we know are governed, secured, etc. And we wanted to manage dependency hell, if you like. So as you are deploying things in your IDE of choice, you're then able to push those down. Anaconda will bring in the relevant packages, in effect, the Python bytecode into a Python secure sandbox. And you do have the access to over 1,000 packages at the moment, and I think they're about to release another 1,000 in a bit over the next, I think, 6 months or a year. But you do have the capability to bring in your own as well and place them in the Snowflake staging location. They just won't have access to the outside world beyond that, just from a security standpoint of view. So from a data frame query API perspective, whether you're working with Python, Java, Scala, you will have the ability to run your data frames. The query translator will convert that into SQL, and it will process that in Snowflake as part of the SQL engine. However, if you did want to use Python and you wanted to embed Python code into Snowflake, this is where you'd simply at UDF for example, and that would tell the object serializer in your IDE to push that Python bytecode down, and then Anaconda would manage all the packages and deployments for you. So, machine learning with Snowflake, we promise transparency. We don't promise to be good at what we're not. We also know that our product evolves over time. So definitely from a pipeline preparation perspective, and we'll show some of this today, Snowflake can be used. It can also be coupled with tooling. I know Wilson mentioned DBT, and there's various other toolings that can be used to, in effect, do your feature engineering and all of that processing side of things to prepare your data from an ML perspective. We don't propose using Snowflake to build models. There are memory restrictions in this regard, and I'm just being open and honest in that perspective. This is a data engineering group, and I'm not here to sell you guys things, so you need to know what we can and can't do. That is an area that we're going to evolve into in the future, but it's not quite there yet. So if you are looking at using sort of Snowflake to build models, you'd package that up with, or in effect work with a partner like Dataiku, DataRobot, etc., to find a tool that will integrate very well with the platform. And then once you've done that, you can then take those models that you've built and actually push them into Snowflake for processing. You also have the ability to call by external functions the various ML platforms. And again, something that we don't profess to do particularly well, and that you'd need tooling for, is lineage, explainability, and drift detection as well. So these are still areas that you probably want to be doing outside of the Snowflake platform. So without further ado, I'm actually at the fun part now. So I'll hand over to Nathan.
Let's jump right in. So I'm going to show 3 things tonight. We're going to start off with some simple SQL expressions on structured data, and then we're going to govern some of that data with some security and data masking rules so that we can define roles, define what access they have to the data. And then we're also going to connect that to some semi-structured data, which is just JSON in this example. We're then going to move over to some processing of unstructured data. So we're going to look at pulling some data out of some PDF invoices, using some Java languages to essentially extract that data out, put it into a table, and then do some analytics on top. And then lastly, we're going to jump into the Python world, and we're going to have a look at Snowpark, which is using the data frame API. So essentially covering all the points around all data, all languages. We want everything. So we're going to cover as much as we can. I've been given, I think, 10 to 15 minutes, but we'll try and get through as much as possible. So if we jump right in, I'll set the scene. Essentially, what we have is a city bike database, which has got a lot of open data that's coming from the bike ride share company City Bike in New York. And what they want to do is share the database with some developers, but actually take some of the PII data out of it so that the developers don't see things like date of birth, gender, all of that sort of PII data. So what we'll do is we'll run this. It's just pure SQL at this stage. So we're going to set our role. I'm going to run this as the DBA.
Sorry, Nathan. Say when you make a form.
Yeah, I was going to say it's probably a bit small. Yes, perfect. Let's just move that across. Now what I'm going to do is I'm going to set up a role for our developers, and that's going to be the dev city bike role. I'm going to grant that access to our warehouse. So we're just going to run that. And just before I move on, just to give you an idea of what the actual data is, let's just sort of move this up a little bit. And essentially what this looks at is you can share your bikes. You have a start station and an end station, and it tracks your geo as well as your subscriber details. So you've got birth, date of birth, gender, bike ID. Now what we want to do is we want to actually basically put a data masking rule so that we can't see this information if we're a developer. So we're going to define 2 rules. One is a string. So this is going to mask any of the strings.
Oops, sorry, Nathan. Your face is kind of cutting off.
Yeah, there we go. Yep. Okay, right. I've just got to reset one thing. I should have done this before. I'm going to take those off. All right. I was just running this before. So essentially, we're going to create a rule that will mask the strings that are returned. Now, what this does is essentially we want to only allow the DBA and the analyst to see the date of birth. So anyone else that's not in those roles will return a masked value. We're going to do the same for integers. So if we want to apply this to an integer type data type, we're going to do the same there. Now what we're going to do is we're going to alter the table, and we're essentially going to set that masking policy for the different data types and different columns. So use the alter table statement. And now what we're going to do is, now I've run this before, so DBA, essentially we should see all the data when we're at DBA. So we'll run that through. You can see that we're getting birth year, gender. Now we're going to switch to that dev city bike role, which is what our developers will use. And we're also going to run that same statement. So essentially here, we're putting some masking, so you can't actually tell what that data is, and then the rest of the data returns just the same. Now that we've got that rule, we're actually going to create a view over the top of it. Or we're going to select from a view, I should say. And even though you've got views on top of base tables, the actual view will honor the masking rule. So if we go right to the left, even though that sits behind the view, we're still masking the data. So we're pretty much ready now to sort of hand that over to the developer team, and we're making sure that that data is going to be visible to them. Next up, I'm going to move quite quickly here, is we're going to look at some semi-structured data. So this is JSON, and essentially we use dot notation. So we've got a variable or a variant data type that we actually store JSON in. And you can actually see here, this is the format. It's hard to move that up and down. Essentially, this is the format of it. We've got some weather data in there, sunrise, sunset, some descriptive fields. What we're going to do is we're going to analyze that, have a look at what the general conditions are in the different city. So New York, Seattle, the type of weather conditions. And essentially, now that we've got that, we can actually start to create a view that will actually connect to our city bike data set that's standard SQL in structured data set tables. And then we're actually going to combine that with semi-structured data sets here. So we're going to run that view. And now we should have a large transformation table, which combines our city bike trip data with weather data. And again, we're honoring that data masking rule. So we combine the two data sets and we're still masking the data. So that is structured data analysis. What I'll do now, and I'll come back to this if we've got any questions, is we'll go to the demo 2, which is going to be PDF extraction. So ultimately what we've done is we've got a stage area, which might be an S3 bucket or it might be an internal stage. We've uploaded 300 PDFs to it with food order invoices. So what I'll do is I'll create that database. Within that database, I'm going to point to where the S3 invoice files are, and I'm going to create a directory table over the top of it. Now, what this directory table has is essentially the file listed. And just to give you an idea of what these files look like in the stage, you can just run an ls command. And you can see here we've got 300 PDFs. They're all of varying sizes. And we've got MD5 if we wanted to sort of verify the contents of them. Now what I'll do is I'll create a stage where I'm going to actually upload some jar files with Java code so that we can start to extract the data out of them. So I'm creating one for our internal stage, one that's pointing to where I've uploaded the PDF extractor. And just to show you what's in there, we've got an open source Java program called PDF Box, which is essentially a manipulation program. And now what we can do is we can create a function that uses that PDF Box app. And that essentially reads a Java or reads a file in from a PDF source. It uses a text extractor, so PDF text stripper. And essentially what that does is it instantiates this PDF text stripper and it gets the text from the document that we're actually inputting, and then it returns that text back to the program. So we'll run that. That's going to create a function which is like a stored procedure. And essentially that function we can actually call by passing in the file that we want to extract the data from. So if we go there, we're going to test it with one file. So the first invoice, we'll run that. And that's going to pull the file in, extract the text from the file. You can have a look there. We've got one invoice. We've got the amounts, got the balance due. We've got the items that are on there. And so we're happy that the function's working. So we're going to then go and create a table, which is going to go through all the PDFs and extract them. So again, that's going to take about a minute. So is there any questions at this stage? No.
Probably the one comment that I would just make is working with the structured data that Nathan showed before. There's about 140 million records from a semi-structured perspective.
I believe so,
and
yeah.
120 million records that were loaded from a structured perspective. None of that we didn't do any tuning on any of that data. Simply by ingesting it in, the data is columnarized for every single column we collect. For every single micro partition, this is how we store the data within the platform. We collect mins and maxes for each of the micro partitions. We collect number of distinct rows. We collect number of rows within each micro partition. And what this ultimately enables you to do is simply by loading the data in, we're able to maximize as much as we can the performance out of the box. And obviously, you've got the ability to go beyond that point to cluster your data however it is that you want, or to do more with it beyond that point. So I suppose the dot notation that Nathan pulled out, that was, we hadn't flattened the data, and it's the same concept for semi-structured data as well. We load it in, columnarize all the data sets, and ultimately optimize it for query performance. So Nathan, when he was showing the semi-structured queries, the 3 seconds that it took to open up that data, give you all the weather conditions by location, etc. That was all done without any manipulation of any tuning from a platform perspective wise or from a data perspective wise. And everything that you're seeing is all delivered by SaaS. So
yeah, I often forget about talking about performance. It's just sort of so quick. I mean, we don't have to index anything. We don't have to sort of run the stats, collect the job. It's all done at the point of ingestion. So if we need to do things like pruning or, in Oracle world, that's partitioning, that's taken care of at the point of the
me and Nathan had many late nights, I'm sure a lot of you have as well, to get data to perform for some of our customers. So this is a breath of fresh air for us.
Absolutely.
Now we're sort of maximizing performance versus making sure that performance is acceptable. So it's kind of a neat position to be in.
So essentially that's gone through, it's created a table with the extract of all the text data in the PDF invoices. Now what we can do is just do a quick select from that table. And you can kind of see that it'll be a little bit raw. So all similar formats. And what we want to do is basically break that down into specific columns so we can start to report on it. One thing you will notice here is that we actually have a file URL object. Now what we could do is actually create an access to this particular table, which would allow people to download the files from our platform. Or we could create views over the top of it that would allow only certain people access to certain PDF files. So that's that sort of pre-signed URL where it's issued a token when the URL is generated, or we can scope it by your role in the system. So the next step is to look at that text, do a lot of regex to sort of get it looking nice into different columns. So you can see we're using just standard regex to pick up the pattern, and then we're going to just turn that into a view. And then on top of that view, we can then put it into nice columns. So we're basically broken down the invoice number, the balances, the items that are on that invoice, the cost. And so we can now start to do some analytics. So top 10 items by quantity. You can see aprons, lettuce, it's a food order invoices. Cost-based top 10. So it looks like the lettuce is taking the win on that one, then the oil. And then the last bit is just looking at some trends, so cost by month. So we can run that through. Obviously, we've got a little chart there that we can bring up. You can sort of see how many invoices that we're fulfilling and the amount of that as we go per month. So that's looking at unstructured data with Java.
How are we tracking for time?
We're going a bit over, but
Okay.
is everyone keen to keep going, or
The next bit's the
Nice.
cream on top.
maybe 2 more minutes? And
2 more minutes.
you reckon,
Okay.
or
We'll see how we go.
Maybe we'll say 5.
Five?
Yeah. All right. So essentially, we are releasing Python processing in Snowflake. So what I've got here is a notebook. Now I'll quickly run through this. So usually I'll just take you through sort of, I'm setting up my environment. I'm using Python version 3.8. I'm installing some Python packages. So that's going away to the Anaconda packages, installing them. Obviously I've done this previously. I'll have to wait for that to go through. And essentially you would have seen in the slides, taking too much time. We've got a Snowflake connector. So we've had that for a long time. That's been our standard Snowflake connector for the last 3 years. In front of that, we actually place a query translator. So when you're running data frames, the query translator converts that data frame into SQL, and then we push that through the Snowflake connector or the Python connector to then run in the system. So I've essentially installed that connector as well as the Snowpark library. And what I want to do is actually just start to set up my libraries for this session. So I'm going to run the session import. So session will actually connect. Version just shows me my version. Windows is window functions, so group bys, all that standard stuff. And I've got some standard built-in functions to call some SQL functionality. Now what I want to do is I want to connect to the instance, so I'll call the session builder and create. I'm going to run some standard queries just to make sure that I'm getting data return. Let's make sure I've got connected. I've got my compute defined, my data set defined, and now we're ready to start querying. So in this specific notebook, I've got the SQL version, I've got the data frame version. You'll see it's very modular. So with a data frame, you essentially tell it what table you're looking at, so line item. You tell it what filters. So in SQL, we're looking at dates 1994 to 1995. And in here, you can see the filter on the column. The quantity is less than 24. So I'll just run that. Now, the beauty of this is it's only at the point that we actually want to see data that we actually submit the query to the server. So we aren't running compute at this stage. We've just told it to structure our data frame with this specific data set. It's only at the point that we actually want to see the data that we actually submit that to the server. So that's going to translate to SQL, give me back a revenue number.
It's in effect lazy execution.
Yep, exactly. The next bit is 2 pandas. Effectively the same as show, but a very nice format. And we can expand on that. So you can kind of see with SQL, you have to join a few tables, put some filters, but it's all in one statement. With data frames, it's a little bit more modular. So you can manage state based on the different data frames. So we're going to bring in customer, bring in orders. We're going to apply some filters on them. We're then going to join based on line items. So the order key with the line item key, the customer with the customer key. We're then going to join. So this is kind of like data engineering. We're doing some transformation. So we're doing a group by window function. And essentially we're going to sort that and just bring back the top 20 revenue countries. So run that. That'll give us top 20 orders. And the last bit, I'll try and get through this, is from a data engineering perspective, you want to start to write that data frame back to a table. So what we provide, I'll quickly just set the session up. So what I've done there is I've actually created a new database. In that database, I'm going to store the table. So let me just get through this. So this function here, the data frame write with overwrite and save as table. So essentially what this is going to do is it's going to take my data frame that we've done an aggregate, we've done a window function on, it's given us our 20 orders that are top revenue. We're going to write that back to a table called priority orders. And then now that that's written to the database, we can then just query that again by bringing it back into another data frame and just making sure that's all there. We've got one more moment. we're going to do a function here. So what we want to do is we want to mask the orders in the system. So we're going to define a masking function, and essentially that's just going to return the last 4 digits of the order number. So think of this as client side. I'm just doing this on my laptop at the moment. So I just want to test that. I'm going to put in a string 1, 2, 3, 4, 5, 6, 7, 8, 9. We want to expect that the last 4 digits come back so that our function is working. So that's return the last 4 digits. We then want to basically push that into the Snowflake database as a function so that we can then mask all the orders inside our table. So we're going to create a UDF, or a user-defined function. This is just for my session, so once I log out, this goes away. So essentially that's going to go away. It's going to create, I might see if I can see this here. So it's going to create a temporary function. Now in that function, new interface, guys. So in here, this is the bytecode that we're talking about. So it runs natively inside Python. And essentially that's this push down bytecode that runs in a secure sandbox. Oops, just put that back. And ultimately what we want to do is we want to run data that sits inside Snowflake through that function that we built to mask the orders and then store the orders back in the database. So we're going to create a data frame here. We're going to create a column called masked order key. We're going to call that function and we're going to pass it the order key. I'm just going to look at five rows. So we should be able to see. There we go. So there are our order keys. You can see it's just returning that masked order. And once we've got that masking function, we can actually then create a view over the top of it. And then with that view, we can return all of our orders in the system with masked data. And that's essentially all the data. So structured, semi-structured, and unstructured data, all the languages, so Java, Python, SQL, as well as data sharing, which we were going to get to next, but essentially there is a marketplace in here where we can then take that data that we've stored, share it with another account, share it internally as a marketplace, or ingest from someone else to enrich our data sets. Thank you.
Sorry, we went
A lot going on there.
Questions, anyone?
Question. I noted the Python definition actually using type is optional or is mandatory?
So the Python definition user type, whether
Typing.
it's optional or mandatory.
Yes.
So you're talking about the user function, the
Yes.
UDF here.
Yes.
So when you define them, you need to define it as a user-defined function with the inputs and outputs that you expect from the function. So that's similar to creating a stored procedure with an input of an integer, a return of an integer.
Okay. So
And
it's
then-
mandatory. You have to have the type.
Well, yes, but we are bringing Python stored procs as well. So that will be possible from pure Python, write code, whatever you want.
Just check if he's got the index on.
Yeah. Yes. That is coming. So that is a feature.
Type pins, right?
Huh?
You mean the type pins, the string?
Yes. Yes. No, I like it. I program like that, but not many
Do you
people
need
do.
those? Or they're optional?
You need them, yes. You need to define for a function what return type there is, yes.
Right, what data frame API is this? This looks very much like Spark
Yes.
API.
So-
Yes, that's exactly it.
Snow Park.
It's Snow
Okay.
with Spark. Yeah, so that's sort of our starting point.
I do have a question, right?
Yes.
So what's the pricing model for the functions on Snow Park?
So there's no additional cost on top of your sort of addition that you're signed up for. So a credit today is going to be worth more with credit tomorrow because you're going to get Python, you're going to get all the functionality. There's no additional sort of contracts or any product lines that you need
It's
to.
going to draw from the standard credits
Yes.
from whatever
That's right.
else you're using out of
Yeah.
that.
Same compute process engine,
Yeah.
just a little process on the side that's actually running the code.
And the key thing there is you don't need a different type of compute to run, for example, your Python code. It's the same compute that you set up. You don't have to specify this for Python and this for SQL. It's the same compute that you find. Same governance as well. You don't have to have separate governance from a language choice. Any other questions? Cool. Well, thank you.
All right, thank you. Great, thanks, guys. All right, thank you everyone for coming down. That's all we have for you. Thank you, folks. Have a lovely evening. Feel free to stay around and mingle around as well. We'll be here for another like 10 to 20 minutes, or 15 rather. We've got a beer to get to. Yeah, thanks for coming down. Cheers, everyone.